Yesterday we heard a lot about the concepts and the theory of how GPS actually works, and today what we are focusing on is actually GPS for research. And we are covering beginnings from project planning to specifics of how to sample for remote sensing, or how to actually generate your field samples. And then in the afternoon we'll be talking about accuracy issues, which receiver should I choose, and we'll actually go into a study. And then we'll talk a little bit about field sampling and actually go out a little bit, take a look at the USGS marker, and also take a look at our GPS course station. So the focus shifts a little bit from theory and from background to actually applied GPS and how you actually use GPS in the field. This is basically an outline that you also find in your book. I'm not quite sure if you can read it here, but please refer to your book for details on the graphics. So we'll start with the data dictionary. GIS database is also an option, specifically now that we are moving away from commonly used like GeoExplorer 2s or ProXRs. We actually collected the points, and it was not necessarily in GIS format. Now with GeoXTs, which we're using in this course, you're actually collecting native GIS format, you're collecting shapefiles. So in that way, the word database, data dictionary, is kind of going out of, and what we're using now is databases, tables, lookup tables. That's what we connect to now. We'll go into more detail on that. Second, what we'll do is field site selection. Basically, where is your study going to be? Then third, satellite availability, required PDOP. You heard yesterday about the importance of PDOP, the point dilution of precision. Then how do we actually configure our GPS receiver? And that again, since we're using the GeoXT in this class, will be mostly on the GeoXT. Then data collection, well, we'll go in the field, and we'll have that actually on Wednesday, and for your class project as well. You'll go a lot out in the field, so you'll do a lot in the field here. Data download, post-processing, how do you actually get your data from your GPS receiver, integrated with your project, integrated with GIS. Then revisions, you can always improve, and then equipment maintenance. Now, in order to plan for a successful field season, it is always a good idea to do a rehearsal first, and then actually the field season. So what we want you to do is, in your rehearsal, you basically complete one full cycle as if you were in the field season, and then afterwards, towards the revision, what you can do is improve upon your protocols and your entire procedure. So if you notice that you didn't collect any points, you had some problem with a specific form, you need to fix that. But ideally, you notice those errors before you go out into the field, right? Because in the field it might be actually days away, you might have to fly somewhere, you have vehicle rental costs and so forth, camping equipment, hotel reservations, whatever is needed in there, so there's a lot of money and time invested in it. So it's always a good idea to do a rehearsal. It could be done right outside of your office. We'll do it right up there on the hill. So a rehearsal is always a good idea to work out all the kinks and get all the errors out of your field sampling. Once you complete it, and you have everything basically to where you want it, then you would actually go out in the field. Then you start your field season, and that's where you do your field sampling. And of course, at the end of the field season, you might notice more problems that you want to incorporate or want to improve upon for the next field season in the upcoming year. So revisions are always part of the cycle. But basically what we want to do is 2 cycles, one for rehearsal and the other one for the field season. So we'll start with the first one, which is Data Dictionary GIS Database. So prior to actually going out, it is important that you actually create that data dictionary or a GIS database or a lookup table. Why is it that important? Well, you're much more efficient if you actually use what you actually collected out there to your point locations out in the field. Some people just record a point location, and then what they do, they write it on a sheet of paper, whatever they saw out there, right? That's not very efficient, because you then have to go in your office and combine those two. So you still have to input your data. So the data dictionary or the database actually allows you very easily to connect what you see out in the field with that location that you record. Now also keep in mind, when you have one of these GeoXT receivers, you don't necessarily see a keyboard on those. So it's quite challenging to actually type in what you see out there. So you have to think about what you'll find in the field. If you're, for example, using this example here, which we'll go over tomorrow in the class, then we want to collect different ant species. And you can see the Latin name, quite long, and prone for misspellings if you're out there. So what we can do, for example, is have this drop-down form. Once you record a point location, what you'll see is on your screen, on your handheld device, is this form pop up, and then you can populate each of these fields using a table that you generated before. And what you'll see then is, in this form, all these different selections that you can choose from. There's no typing in the field. All you do is select one of these species, in this example, ant species. So that's all you have to do, but you have to create that before you go out in the field. And specifically, that's how it looks in ArcPad. There are other programs out there, but in this class we'll be using ArcPad. So basically, our goal here is to assign values to locations in the field without having to type it in, so that we just select it from a drop-down menu. Field site selection. Well, the field site selection, well, the big one is of course where do you actually sample. But it's also important to consider when you sample and how you sample. And at this point, of course, I assume that you already selected the what, right? Otherwise you couldn't have built the database dictionary. So, important considerations for where is your general study area. So for our field season, it's, for example, the Big Desert allotment. But then once we have that general area, it is also important sometimes to select specific locations. And you'll hear about that in the upcoming lecture, for example, about validation for remote sensing. So you want to select specific locations, generate a point file, and then visit those locations out in the field. So not only do you have a selection of the field area, but you also selected specific locations where you would like to sample what you see on the ground. So that's the where. Then when is also important, specifically if you want to observe temporarily changing variables. For example, snow cover. Right? In the summer, you won't find too much snow out there. Or wildlife. When is the wildlife actually migrating through here? Or phenologic cycle in a plant. When is the plant dormant? When is it active? So it's important that you actually consider when you would like to go out in the field in order to observe those variables. Then how to sample is important for consistent field sampling. For example, if we all go out and I tell you, please record the age of this plant using the stem diameter. Well, everybody will measure it at a different distance from the ground. So if everybody of you goes out there, there's no consistent way, no consistent protocol of how to actually measure the variable. So if there's more than one person, or even if it's just one person going out at different times, you might forget where you actually sampled. So it's always a good idea to document, to share, and to rehearse how you actually want to measure your variables. It's important, most important for consistency. And then, of course, it also depends on how you want to sample it, with what you want to do with your data. Do you just want to record an inventory? Do you want to use it, for example, to validate remote sensing? So that what you want to use the data for is also important how you collect it. Now, other considerations that I would like you to kind of associate it with the field site selection, with the field sampling, is do you actually have permission to go onto the land? Or will you find a farmer there with a shotgun? Has happened before. Then where do you actually camp? So if you're in a remote site, do you take your camp out? Do you take a tent out there? Do you drive back 2 hours to the nearest town? Actually rent a hotel? And then also include emergency planning. So in an emergency, what do you do? I mean, you're in the field, it's uneven terrain, you have to walk out there might be snakes out there. What do you do? And most of the big desert, actually, you don't have any cell phone coverage. So one of the important steps there is, for example, to get a satellite phone, rent a satellite phone. So these would be all considerations for your field site selection, and actually also how you actually want to collect in the field. Now, additional considerations specifically for ArcPad is background data selection. So what kind of backdrop would you like to have when you're out there? For example, would you like to have the roads data set? So you can load the roads data set, you know where to actually navigate to your field site. That would be important. Or would you like to have vegetation cover, so that you see where you can go through or cross pasture, or if you have to go through woods? So what kind of backdrop additional support data would you like to load? And then also generate a project, and we'll come back to that when we actually go to ArcPad tomorrow. But it is part of that entire cycle to generate a project. And then, of course, copy your project data onto your handheld device. In our case, that would be a GeoXT. So once you have that data dictionary and everything else, how you're going to sample, you need to create a project and upload it to your GeoXT. But more on that tomorrow. Then the third step in this cycle is to actually take a look at the satellite availability. Well, we know the satellites are not stationary, so there's always a different constellation out there, right? So now it is important, specifically because you have always a different PDOP, and visibility obstructions, you have to consider those as well. If you're, for example, up in the Swan Valley, where you have a deep canyon, you won't see the entire sky, you won't see the entire horizon, but you only see a narrow wedge, a narrow mask of it, right? So how many satellites do you actually have to see if you're down in that canyon on that small portion of the sky? How many satellites do you have there? At least 4 satellites. So in most instances, you're actually lucky if you get a good PDOP, you know, if you're on even terrain with 4 satellites. So especially if you're in a canyon, your time window when you can actually observe is very narrow. It's happened before that you have to go out at 3 a.m. Otherwise you won't find 4 satellites down in that valley. Then you might have specific accuracy constraints where you require a certain PDOP. So don't go beyond a PDOP of 4 or 6, whatever you specify. Then what you can actually use to plan this is use the almanac and plot the satellite availability and the expected PDOP. Here, for example, if you planned to go out somewhere between 3 and 4 in the afternoon, then it was not a very good idea, because your satellites, the available satellites, drop down to 4 or 5, and your PDOP actually goes up beyond 20. So here, and Keith will show you how to do that using Pathfinder Office and the almanac, you can actually plan and see what PDOP you would expect out there. Of course, these planning cannot consider if there's, for example, a building or a huge tree with thick canopy cover, right? So, but this gives you a general idea what you can expect for a PDOP. This program also allows you to insert an elevation mask, basically what we referred to back up here in your valley. So you can basically mimic the situation you will find out there using that elevation mask. And then it will show you when you have a PDOP that is suited to you. And here the number of satellites that are available. 4 in the cycle was to configure your GPS receiver. Well, first of all, we have to select a protocol and a datum. And again, here I'm using the example for the GeoXT to set all these GPS receiver configurations. Is the protocol, the first option here, and one of the protocols is, for example, NMEA 0183. And another one would be, for example, GPS correct, and we'll come back to that. But here you can basically set the protocol, which is a standard that allows to communicate the program with the GPS receiver, and that's a certain protocol. Then the GPS datum. The native GPS datum is WGS84. Here, for example, we also use the datum NAT83, North American datum 83. But the satellite system, the native coordinate system for the satellite for GPS is WGS84. Whenever you select a different datum here, you use the specific software's coordinate transformations to go from WGS84 to whatever you specified. So here, word of caution, not all transformation programs here are perfect. So a good idea is always to collect in WGS84 to avoid any of the software-specific transformation issues. Then something that's also for communication between the program and the GPS antenna, the receiver, is actually which COM port and COM port, communication port, that's basically also on your computers. Where do you want to plug in your printer? That's usually also COM ports. Then at which rate is the data actually transmitted? That would be the baud rate. Data bits, how many stop bits do you have, parity, and so forth. You don't really have to become an expert in this. All you have to be able to do is read the help files and find it in the program where to set it. The help files on the receiver, the manual on the receiver. Usually just open the manual and you'll find all these different settings that it requires. Then you want to select maybe the quality. So basically here one of the options is you can select a maximum PDOP, which basically says do not collect data if it's not in consistency with my PDOP desires. Make sense? So if your PDOP gets worse, do not collect data. The capture options. Here what we can do is, for example, enable averaging, so that you want to collect at least, let's say, 100 points in order to collect 1 point. Then you average all these points that you collected. Or streaming vertices, if you can just turn it on, walk along a line, and it will collect every 2-3 seconds. Or if you walk a polygon, same thing here. So this streaming vertex interval works for lines and for polygons. Now, other settings that you can actually set in your GeoXT receivers that you will get is we also installed GPS Correct. GPS Correct is specifically for differential corrections, and you heard about that yesterday. And the two options that you actually have is real-time differential corrections through WAS, wide area augmentation signal, or post-processing. But for post-processing, what you also need to collect is the SSF file, and it also sets restrictions to the protocol. You have to select GPS Correct as one of the protocols, which is supported by all Trimble, by most Trimble antennas, but not by other receivers. So if you use, for example, an iPAC and you use some GPS antenna that you can plug in your secure digital slot, or just with Bluetooth connection, like a Ferris antenna, those are not capable of collecting all the signals that are required for post-processing. So yes, ArcPad will run on other handhelds as well, but one of the disadvantages is that you cannot select to collect SSF files, which are required for post-processing. But make sure that you configure the GPS receiver to collect whatever you want, either real-time WAS or post-processing. Now, you can also select both. You can do real-time WAS first and then post-processing in the office through the SSF file. Where we actually found that WAS is not all that beneficial to us, especially in this area here. And we'll go into more detail about that. Point number 5, well, more to come during the week, is actually data collection in the field. What we'll use is the Trimble GeoXT that you can see in this picture here, and we'll show you more about field sampling when we go outside. The next step would then, once you collected the data, is to download your data and post-process your data. Well, to download your data, and that's again an advantage now moving towards the GeoXT and ArcPad, is since you already collected in native GIS format, all you have to do is download those files. And you basically have all your point collections, all your attributes are in there. It's basically in your DBF table of your shape, all the values that you collected out in the field. Everything, all you have to do is use ActiveSync, connect it to a USB port on your computer, and download the data. And it's a shapefile. So there's no other post-processing, as in importing a text file, making that into a shapefile. None of that is required because you already downloaded a shapefile, because you collected a shapefile in the field. Post-processing, what you might have to do, if you have chosen to select SSF files, is to go through Shape Correct. Shape Correct is, again, Trimble software that is through Pathfinder Office, and Shape Correct actually allows you to differentially correct shape files directly. So all you have to do, download the data that you collected, meaning the shapefile, get it through Shape Correct, and it's post-processed, differentially corrected. Integrate with GIS. Well, this step again, since we're using ArcPad, is pretty straightforward because you are using shapefiles directly. Additionally, what you can also do is actually integrate your collected data into a geodatabase. Build relationships with other data sets that you might have in your geodatabase. But again, what we start from is a shapefile. Step 8, revisions. Well, revisions are always a good idea, no matter what you do, but specifically here with GPS collection, what we want to focus on is check your data for obvious error and completeness. Basically, did you really record everything that you wanted to record? Do you have some points missing? Were there some problems with some files? What did you miss? So that is important. Check your data for errors, obvious errors, and completeness. Create a backup of the data. Always basically have some form of protocol that tells you at the end of the field sampling day, what you do is you connect your GeoXT to your laptop, download all the data, and back it up. Or burn it on a disk, burn it on a USB stick, whatever you wanted. Have some way of actually backing up the data that you collected in the field. Why? Well, you invested a lot of time and money in order to get that data, and that data is worth quite a bit. So you want to make sure you have a backup. Don't just let it sit on the GeoXT for the entire 2 months of the field season. Back it up whenever you can. Then also revise your procedure and protocol based on your experiences. See what worked, what didn't work, and basically improve upon that. And that's basically very important for our rehearsal. So when we just go out before the field season, that's the spot to hit all the errors and improve upon them. Does that make sense? And then of course, even in the field sampling season, what you'll notice is some small glitches that you want to improve upon in the next year. So also write those down and make sure you incorporate them in the next field season. Equipment maintenance. Clean your equipment. It's worth a lot of money. We had a 4800, Trimble 4800, and it was so dirty that we couldn't even see the Trimble yellow. Right? So it was a $40,000 equipment, and you couldn't see the screen or anything else because it was so muddy. Clean it. Yes, it might get dirty in the field, but clean it. What we also noticed is, especially with the screens on the GeoXT that you see, is when you go out, for example, in the big desert, what you see is a lot of dust, sand on the screens. So when you write with your stylus on the screen, what you'll do is also you'll scratch it, right? So always put screen protectors on there, and usually after a week or so, what we noticed, when you have a lot of sand in the air, you'll scratch those screen protectors right off. So replace those screen protectors whenever needed. And then of course, charge your batteries. That's the main equipment maintenance. So again, what we did is the entire outline here. Basically, that's easy because in the field you want to assign the value directly to your location. Then field site selection, where do you actually want to go? Where do you want to have your samples? We'll talk about random samplings and sampling design in the next lecture here. Then satellite availability, required PDOP settings that you might have. Consider elevation masks, consider times when you actually have a PDOP that is not suitable to you. Use the almanac for that. You know what the almanac is? It's basically all the position of the satellites at a specific time. Then configure your GPS receivers. Make sure that you set everything that you need. Protocol, quality capture, for example, GPS correct, how would you like to do that? Real time with WAS, only post-processing, not at all. It's up to you. Then data collection, go out in the field and collect it. Data download and post-processing, you'll download the data and post-process it. Very straightforward. If you don't collect differential correction option, you just download it because it's already a shapefile. If not, run it through Shape Correct and it's differentially corrected. Integrate it with GIS, for example, put it in the geodatabase. Revise the entire procedure, specifically that applies to the rehearsal. Do the rehearsal as if you go out in the field, and then you notice where you have problems with any of these steps. And then, of course, equipment maintenance, keep it clean, keep the batteries charged. One more thing, and that is specifically to ArcPad, and that's more of a file management hint. What we'll do is, in ArcPad, all your forms, basically the data dictionary, what we talked in the beginning, all your forms are associated to shapefiles. So what you'll do, and we'll do that in the next couple of days, create an empty shapefile and associate that form with that shapefile. Then you collect data in that shapefile. Now once you save that, what you ideally kept is a copy of the original empty shapefile with your form. And that's what you're going to use the next day. So just keep in mind that there is some file management that makes this procedure very easy. But you'll actually notice that once you come to your revisions and prepare for the next day. And there are other things that we noticed. For example, for differential correction, you cannot go over the weekend. So always use a file. That's why I always tell you back up often, especially at the end of the week. Use that file, then you can differentially correct it. It won't allow you to collect on the next Monday. That's one of the issues we came across. So don't use the same file for more than 1 week. Otherwise you'll run into problems, especially for differential corrections. But we'll come to more of those details as we actually program for the GeoXT and actually put that together. On the GeoXT itself, they don't have a USB port, so that you could use a USB stick to back up your data. So that's why we have a field laptop where you just back up your data to.